2.5, reasoning in geometry and algebra. We start with this chart, and this chart is all the different properties that are going to come into play, most of the different properties that are going to come into play. Yes, ma'am? So the notes are, if you go to the top of the Chapter 2 module, there's Chapter 2 notes and Chapter 2 book pages. It's in that Chapter 2 notes page. And then there's 2 links there. We're doing the 2.5 to 2.6 notes. Okay, so let's just take a look at these. You know these. You do these all the time right now, okay? You maybe don't know that they're called what they're called, but you do them all the time. The first one is the addition property. And basically what that is it says if you know that A and B are equal, you can add the same thing to both sides and they will still be equal, right? Here's an example. If I give you x minus 4 equals 10, what do you do to solve that? You add 4 to both sides. That's the addition property. I can add the same thing to both sides and I still get a true statement. X equals 14, right? So that's the addition property. The subtraction property says I can subtract the same thing from both sides. So if I have x plus 2 equals 10, I'm subtracting a 2 from both sides. That's the subtraction property, okay? So not new, right? You've seen this before. Multiplication property says I can multiply both sides by the same thing. So like if I have 1/2 x equals 10, if I multiply both sides by 2, I would be solving that equation, right? That's the multiplication property. And then the division property says we divide both sides by 2 or by whatever it is we're dividing by. Okay, so these ones you do day in and day out in math class. That should be nothing new, okay? Addition, subtraction, multiplication, and division. The 3 that are probably new to you are these next 3. The reflexive, the symmetric, and the transitive properties. And these ones are properties of equality, meaning we're doing this more in an algebra sense, but in a little bit you'll see the properties of congruence, and that's more of the geometry sense. So the idea is the same, it's just a matter of what symbol is between them. The reflexive property, okay, think your reflection in a mirror, right? If A looks in the mirror, he's gonna see A back. Okay, so A equals A, and people are always like, that is a ridiculous property. Why do we need a property that says something equals itself? You'll see, it comes into play quite often, okay? That's probably the property of these next 3 that you use the most in geometry, is the reflexive property. So it's basically like saying 7 equals 7, right? A equals A, that's the reflexive property. The symmetric property, think of a line of symmetry. If I have a line of symmetry, whatever's here gets flipped around when I reflect it over to the other side, right? So if A equals B, then the symmetric property says, well, then B is going to equal A as well. Okay, so think symmetrical. If I were to draw a line of symmetry and flip it over, that's what we would see. And then transitive property, we do a lot with the transitive property too. Here's the thing, the transitive property, you can think of kind of like the law of syllogism. It's very similar to the law of syllogism, just without words. So transitive property says if A equals B and B equals C, take the 2 out in the middle, and what you're left with, A equals C, will be true. Okay, if A equals B and B equals C, then A is going to equal C. And then the last one, you've done this before in Algebra 1, that's substitution. Remember substitution, elimination, all the solving of systems. This is substitution. So basically it says if I know A and B are equal, then I can take B out and put in an A, or I can take A out and put in a B, and it's still a true statement. Okay, so we're just substituting. Think basketball, right? If you have a point guard in and you take him out, you probably want to put another point guard in because you need a ball handler, right? So you're replacing something of equal value. Now that's not the perfect example because usually they aren't equally yoked players. That's okay, but think of it that way. Any questions on those properties? Okay, and then the distributive property, again, you've done this a million times, right? Distributive property says if I have 2 times x plus 4, that's going to become 2 times x plus 2 times 4, right? That's the distributive property. So that's what this is saying. If we're adding, subtracting went away. Here's the subtraction one. This would be a times b minus a times c. Okay. Okay, so here's what we're gonna do. This question is nothing new to you. You've seen questions just like this where they ask you to find the value of x, but now they're asking you to justify your steps. Whenever they say justify, they're saying prove it to me. Prove that this is actually what works and why it works, okay? So here it is. I'm giving you all the steps. You're gonna tell me why it works, okay? So the first thing, it says the measure of angle AOM and angle MOC are supplementary. How do I know those 2 angles are supplementary? It's a straight line. They are a linear pair, right? Straight line, a linear pair, okay? So if I know that, then I go to this, the measure of angle AOM plus the measure of angle MOC has to equal 180 then. So think about what we've already said. How do I know they have to add up to 180? Yeah, Bradley. They're supplementary, right? It told us here that they're supplementary. That's just the definition of supplementary angles. Right? Supplementary angles are 2 angles that add up to 180. Okay. Okay. Now your third step. We went from, and I tried to color code here to get you to notice, AOM to 2x plus 30. And we went from MOC to x. What is that? Substitution. We took out a point guard and we put in a different point guard, right? We took out the name, the measure of angle AOM, and we put in what it equals, right? So that's just substitution. Okay. What did I do next? How did I get from this 2x plus 30 plus x to 3x plus 30? We added our x's, okay? So here are your options. You can call it combining like terms if you want, which is a little wordy. The one that I like is we're just simplifying, right? I would just say this is simplify. If you only do it to one side of the equation, you may call it simplify. If you're doing it to both, then it's one of the properties, okay? But if we're only doing it to the one side, that's simplify. Okay, so now look at the next step. To get from 4 to 5, what's happening? Not division. We're not adding. Subtraction, right? We're subtracting 30 from both sides. So this is the subtraction property. If you're doing it to both sides of the equation, it's a property, right? Subtraction property. Whatever you do to one side, you do to the other. Okay, so what's the last step? The division property. We're dividing both sides by 3. Okay, so you guys can do this for me now. We did that in chapter 1. We learned that process, right? This is the new part. Tell me how you know you can do it. Justify it for me. Give me the reason behind it, okay? That's essentially what a proof is. Here's what I did, and here's why I did it. And then here's what I did, and here's why I did it. And then here's what I did, and here's why I did it, okay? So we're gonna do plenty of proofs in the next few chapters. We'll do a few in chapter 2. We do a lot in chapter 4. Chapter 4 is a lot of proofs. It's also one of my favorite chapters. I know, I like them all. I really do like 2 and 4 a lot though. They're good.
You're obligated to say them.
No, I don't feel obligated. There's things I don't like. but I like a lot of things. Okay, so like I said before, those first properties that we saw, those are properties of equality. Those are algebra-minded properties, okay? These three we saw with the properties of equality, but these are properties of congruence. So they're gonna deal with segments and they're gonna deal with angles, but they're the same idea, okay? This first one, the reflexive property, says a segment equals itself. Segment AB equals segment AB, or is congruent to segment AB, okay? Then it says angle A is congruent to angle A. That's the reflexive property, okay? Symmetric property, just like we said before, if you take those two things and put a line of symmetry, they will smack each other when you fold your paper over, right? If AB is congruent to CD, then CD has to be congruent to AB, and vice versa. Same thing with the angles. If A is congruent to B, then B is congruent to A, okay? And then the transitive property, just like we said before, just like the law of syllogism, if you will. So if A is congruent, AB is congruent to CD, and CD is congruent to EF, take out the two that are the same, and AB will be congruent to EF. And then same with the angles. If A is congruent to B and B congruent to C, take out the two that are the same. Notice here, they did them in a different order. If B is congruent to A and B is congruent to C, then A is congruent to C. That's the transitive property. I will take substitution for that as well, because you are substituting something that you knew was of equal value. So transitive and substitution are usually pretty interchangeable. All right. Okay. Grant, I haven't seen your eyeballs in a long time. Are you with me right now? Yeah. Okay, so example 2. We're going to name the property that we're seeing there. So if you look at letter A, and this isn't just the congruence properties, this is any of the properties, okay? How did we get from here to here? Addition property. And I'm not picky about of equality. If you just tell me the addition property, I'm great with that. Excuse me. So that's the addition property, okay? Look at the next one. O is congruent to L. W is congruent to L. So O is congruent to W. What is that? That's the transitive property, yes. Remember, kind of like law of syllogism. Get rid of the two that are the same. What you're left with will be your answer. Okay, and then last one of these, it says E is equal to T. So therefore, T is equal to E. What is that? Symmetric. That's the symmetric property. Reflexive is the one that's going to say T is equal to T, right? It's equal to itself. Symmetric is the one that says they switch places on you. Okay. Questions on that? Okay. Last thing then. 2-column proofs, okay? Here's the thing. Your book at times is going to ask you to write a paragraph proof or to write a flow proof. I don't need any of that. We're going to do every single proof, whether your book says to or not. Every proof you do is going to be a 2-column proof. It just simplifies life. It makes more sense. It's the easiest route. So we're going to do that, okay? 2-column proofs always. Don't ever do a paragraph proof. I don't care if it says to do a flow proof and they have the flow proof set up for you. I don't care if you fill in the gaps, but typically we're going to go 2-column proof, okay? So here's what I'm going to do. I'm going to show you the general format of a 2-column proof, because there are things that if you get them wrong on a test, it's only because you just don't pay attention. Easy points on proofs if you're just paying attention, okay? Are you ready for your easy points? Here they are. So you notice here, these two problems are identical. I'm going to show you on this first one the things that you should never get wrong, okay? Then we'll work through an entire proof and show you kind of how the flow goes. So these are the things that if you get this wrong on a test, I'm going to roll my eyes at you, okay? Here they are. In a 2-column proof, this box right here and this one right here, are always the given information. Okay, so look up here. It says given that the measure of angle 1 equals the measure of angle 3, prove to me that the measure of angle AEC is equal to the measure of angle DEB. Okay, so step 1 of every single proof. Now, sometimes your book doesn't do it this way. I promise every quiz, every test, your step 1 is the given. Okay, don't get it wrong. That means this goes here. The measure of angle 1 equals the measure of angle 3. The reason we know that is it was given to us. Okay? That will be every single one. Don't get that wrong. I want to cry when people don't write given for step 1. I really want to cry. Okay? So just note for yourself, step 1, the given. Step 5 is the prove information. Now, you're only going to know this piece of it, okay? You have to figure out why you know it by finding all of these pieces first. But that information is this information up here. We're going to say the measure of angle AEC equals the measure of angle DEB. Okay, so those are 3 things that never change. It will always be the given information in step 1 and what they asked you to prove as your final step, which makes sense, right? They're saying, prove to me that these angles are equal. Well, once you say those angles are equal and here's why, you should be done with your proof, right? Okay, excuse me. When you do a proof, the picture is the most important thing. I'm going to move this a little bit because I feel like it's kind of far out there. And I want to zoom in. Okay, so here's how it goes. Given that the measure of angle 1 equals the measure of angle 3, right? That's marked for you. Markings matter. Prove that AEC is equal to DEB. So we're trying to prove right now, you don't need to mark this, but I just want you to see AEC. We're trying to prove that angle, AEC, is equal to this angle, DEB. Okay, trying to prove those angles are equal. So let's think through this. What is step 1 going to be? Reynard? The given. Thank you. The measure of angle 1 equals the measure of angle 3 because it's given. Okay. By the way, anytime angles are marked congruent for you, you can just say given. If they have the markings, it's given. Even if it's not written in the given, it's given, right? They told us they're congruent. Okay. So that's given. Then the next thing we're going to say here, if you notice both of those angles, the like blue-green angle and the pink angle, they share something. What do they share? Give me a number. Angle what? Angle 2. This piece of information, right? That overlaps both of those angles. So we're going to say right now that the measure of angle 2 in the one angle is the same as the measure of angle 2 in the other angle. Which property is that? That's reflexive, right? So we know that angle 2 in the one is angle 2 in the other. Okay, so that's the reflexive property. Okay, now think about the information we have. We said 1 is congruent to 3, and we said 2 is congruent to 2. So if I add angle 2 to my angle 1 and my angle 3, are we still equal? Yes. If I say the measure of angle 1 plus the measure of angle 2, it still equals the measure of angle 3 plus the measure of angle 2. What property is that? I added angle 2 to both sides, right? That's the addition property. Okay. Okay. 1 plus 2 represents what big angle? Name it for me. AEC, right? So instead of saying 1 plus 2, I could say, well, let's do this. The measure of angle 1 plus the measure of angle 2 is equal to the measure of angle AEC. Okay, and then in that same fourth step, because they're the same reason, it's doing the same thing, we're going to say the measure of angle, oh, there is a tiny ant running across my screen right now. Not anymore. The measure of angle 3 plus the measure of angle 2 is what angle? BED. Okay, or DEB is the way they set it up there. It's the same angle, so it doesn't matter. How do I know that? Do you remember? Do you remember the property that said this angle plus this angle equals the whole thing? Angle, addition, postulate, right? And we learned this segment addition postulate that said this segment plus this segment equals the whole thing. That's all I said right there. Angle 1 plus angle 2 equals the whole thing. So that is the angle addition postulate. Hitting different colors. So angle addition postulate. And now I already said that these two were equal to each other up here, right? If those are equal to each other, then that means I can put this one in place of that and this one in place of that, and I can say, and you know this already, your last step is always the prove thing, right? So now I can say the measure of angle AEC equals the measure of angle DEB, or BED is fine. How do I know that? Substitution. I took out a point guard. I put a new point guard in, right? I substituted. So that's substitution. That's a proof. Do you love them?